Hello CS300 and welcome to this tutorial on deep versus shallow copies of arrays. So I'm going to be using Java Visualizer to demonstrate this, and of course I'm going to be turning on this option here to show the actual memory basically for objects, which will make a couple examples later a little bit more clear. So if you're going to play around with this yourself, be sure to turn that on. So I have a constant here that I'm going to be using to make first two primitive arrays. I'll call it old equals a new int num, and then can't really call it new, that's a reserved word. We'll just do new one, which is a terrible name, but whatever. And let's say we have some data in our old array. Oops. And we'll just say old of I equals I. It's probably easiest. And so we have this data. I guess we didn't actually have to initialize it because I'm about to initialize it again here to old. And so right here, I have just made a shallow copy of our old array. So they're the same size, same everything, and it's really easy, but the thing is, this again is a shallow copy, which just means that it'll be reusing some memory, which is great for memory utilization. But if you see, once we visualize or execute it, that this is now pointing to the same array in memory. And so if I change new one of I, no, not I, sorry, of 3 to 3 whatever that is. Okay, too big of a number, got a little too excited. Then that will also change the old arrays, I guess fourth element here. And that can be a big issue. Maybe it is, maybe it's not. It really kind of depends on you as the programmer, what you want to do. But if you don't want that and you want to create a separate instance of your array when you're copying it over, then you want to do a deep copy. And for primitives, that's pretty easy. It's easy for objects as well, I guess, or non-primitives as well. But all you have to do really is make another for loop. I could do it in here, but I'm not gonna, because we're pretending like the data already existed before this for loop. And then I would just do new one of I equals old of I. And now it's going to be individually copying each element over. I do believe I would have to now initialize it with the null values first. And so now you can see there's two separate arrays. And so if I were to change new one of 3, then now, I guess maybe obviously it will not change the old array, which is maybe helpful. I'll quick do a demonstration with objects because I think that's it's good to show this as well. It's not too different. One thing is though, well, I guess I'll show you in a second. Okay, everything else should be good. It's not quite a deep copy with this because if you look, this is really messy, but it's also helpful. If you look, each number or integer that is the same is now sharing the same integer instance in memory. So they're not the same array. So if you change one, it still won't change the other one, but they are referring to the same, each element is referring to the same integer instance. If you want to make it a truly deep copy, then you should actually just specify that it's a new instance of that object instead. And now you can see when I do this. So now with these separate integer instances, this takes up a whole lot more space in memory. So it's not really necessary because, like I said, even without this new integer here, it's this new array is not going to interfere with the old one. But if you really want to make it a true deep copy, then that's pretty much what you do. So yeah, that's pretty much all I have for you guys today. I hope this video helped out, and good luck with your program for this week.